7.6. Mr. Thompson is about to give one of his students a piece of candy for asking a good question in class. Oh, he's nice. He's going to choose the piece of candy at random out of a bag he brings. He has 10 apple gumballs, 6 grape gumballs, 14 apple suckers, 11 grape suckers. What is the probability that Mr. Thompson chooses a grape or a gumball? Okay, so this would be grape, and this would be gumball. Is there any overlap between those two? Are there any grape gumballs? No, it's either grape. Oh, sorry. What is the chance? Okay, grape or gumball. I'm sorry. And gumballs. So, how many grapes are there? There are a total of 17 grapes. How many gumballs are there? 16. Okay. How many are both grape and gumballs? 6. Right? So how many grapes are there that are not gumballs? That would just be the suckers. And how many are gumballs but not grapes? 10. So what is the probability of grape or gumball? Can I add those together? I can, but the answer is going to be too high. It's going to be 6 too high. So if I did 17 plus 16, I'm counting this twice. So you could do 17 plus 16 minus 6, or the other way to calculate it would be just add those together. So 11 plus 6 plus 10, and that is 27. Okay, so that's the number. What's the probability going to be? How many pieces of candy does he have in total? 20, 30, 42, right? 41. How about 41? So the probability would be 27 out of 41. Does that make sense? Okay, let's do another one. Oh, wrong button. At Bob's Auto Plaza, there are 6 new cars, 7 used cars, 11 new trucks, and 7 used trucks. Bob is going to choose one vehicle at random. What is the probability that he chooses used or car? So we have 6 plus 7 cars, and we have 7 plus 7 trucks. But that counts, so this is a new car, used car, and then used car and used truck. And we counted this one twice. So if I only count it once, the answer is going to be 6 plus 7 is 13 plus 7 is 20. How many are there total? So 13, 24, 31, like that. Does that make sense? All right. A certain pizza parlor, 51% of the customers order a pizza containing onions, 44% of the customers order a pizza containing sausage, 65 order a pizza containing onions or sausage or both. Find the probability that a customer chosen at random will order a pizza containing both onions and sausage. So here is onion, and here is sausage. Okay. So I know that onions are 51%. And I know that sausage is 44%. What about this one? What is 65? Where does that go? So this circle here is 51, and this circle here is 44. But if I add those two circles together, I get 65. So how many are in there? How would we figure that out? Well, what if they didn't intersect? If they don't intersect, this is 51 and this is 44. When I add those together, I get 95. Right? So how much of an intersection do I need in order for that number to be 65? Well, if they don't intersect, then the total is 95. But if they do intersect and the total is 65, how much is in the middle? It must be 30. Right? Because when I add these together, I get a number that is 30 percentage points higher than it should be. So 95 minus 65 is 30, and let's try it. So if I put 30 in the middle, how much would be here? Well, this total circle is 51, and if 30 is in the middle, then this would be 21. And how much would be here? Well, 30 is in the middle, and the total amount is 44, so 14. Now let's check. What is 21 plus 30 plus 14? 65. So the center is always going to be the difference between no intersection and this. Let's do it. Another one. So investments are 51%, and bonds are 47%. And where do we put the 28? It says both. So in this case, the 28 goes here. What is the probability that a person who inquires about investments will invest in stocks or bonds? So that would be both of them put together. So what is this number going to be? It's going to be 51 minus 28, which is 23. And what is this number going to be? 47 minus 28 is 19. And then this is going to be that plus that plus that. So 23 and 28 is 51. 51 and 19 is 70. So 70%. Okay, let's do another one. All right, we have doctors are 66%, And women are 65%. And doctors or women, so that would be both, would be 69%. So how many female doctors are there? So that would be this group here. Well, if those two did not touch, then we would get 131%, which obviously makes no sense, right? Okay. So how many go in there? Well, it's going to be the difference between this and this. So 131 minus 69 is going to be 62, which means this is a 4 and this is a 3. So how many are female doctors? 62%. Okay. Do you need to see another one? One more? Okay. So a geology A is 63. A mathematics A is 57. And then 42 is both. So this is 42. And it wants to know, what is the probability that you get this one or this one? So we just need to figure out how much is in each of those. 63 minus 42 is 21. 57 minus 42 is 15. And then we just add all three of those together. 21 plus 42 is 63, plus 15 is 78. 78%. Does that make sense? All right. Is it getting hot in here? Okay. We'll let it ride. All right. A 6-sided dice with faces 1 through 6 will be rolled. The 6 possible outcomes are listed below. Note that each outcome has the same probability. What is the probability of rolling an odd number? So we're just going to go through, we're going to check every odd number, and then the probability is going to be 3 out of 6 or 1/2. What is the probability of rolling a number greater than 4? Does 4 count in that case? Is 4 greater than 4? No. So it's just going to be this one and this one. So 2 out of 6 or 1/3. What is the probability of getting A or B? So if I am playing A or B, that is everything in A and everything in B, but I don't want to count this twice. I only get to count that once. So it would be 1, 2, 3, 4 out of 6, or 2/3. What is the probability of rolling an odd number and a number greater than 4? So how many of my outcomes are both bigger than 4 and odd? Just the number 5. So this is the only one that counts, so 1 out of 6. So A we call a union. It's everything in A combined with everything in B. And we call an intersection, and that's only where A and B both happen. Okay, so A is the probability that the student is in the basketball club. There are 8 students. What is the probability of randomly selecting a kid that is in the basketball club? That would be 3 out of 8. It's everybody in here. Okay. What is the probability that the student is in the chess club? That would be 6 out of 8, or 3/4. What is the probability of A and B? Would just be those people. So 2 out of 8, 1 out of 4. What if I wanted A or B? What would that equal? Well, we would include everybody in A and everybody in B, and that would be 7 out of 8. All right. That is it. Get to work.